Space is vast and mostly empty, but it's not entirely harmless. Asteroids, remnants from the early solar system, hurtle through space like bullets in a cosmic shooting gallery. Most are harmless, too small to pose a threat. But some, the size of mountains or even cities, could cause catastrophic damage if they collided with Earth. Remember the dinosaurs? They didn't have a space program. We, on the other hand, have the ability to protect our planet from these cosmic threats. And in 2022, NASA took a giant leap forward in planetary defense with the DART mission. The DART mission had one primary objective: to change the trajectory of an asteroid, a task that seemed almost impossible. Sounds like something out of a science fiction movie, right? But this was real, and it was happening now. This was humanity taking control of its destiny. A monumental step forward. The mission was crucial for several reasons, each more important than the last. First, it was a proof of concept, a test of our capabilities. Could we actually deflect an asteroid if we needed to? The answer was yes. Second, it provided valuable data that will help us refine our asteroid deflection strategies for the future. And third, it showed the world that we are serious about protecting our planet from potential threats. The success of DART has far-reaching implications for our future. It means that we are no longer helpless against the threat of asteroid impacts, a significant achievement. We have the technology, and now we have the experience, to protect ourselves and our planet. For this planetary defense test, NASA chose a binary asteroid system called Didymos. The larger asteroid, Didymos, is about half a mile wide. Orbiting it is a smaller asteroid, Dimorphos, about the size of a football stadium. Dimorphos was the bullseye for DART. Why target a moonlet instead of a larger asteroid? Because it was safer and easier to measure the results. Changing the orbit of a smaller object around a larger one is simpler than trying to move a single asteroid all on its own. This binary system provided the perfect natural laboratory for testing our asteroid deflection technology. It was far enough away to pose no threat to Earth, yet close enough to observe the effects of the impact. DART wasn't carrying any lasers, explosives, or other Hollywood-style weapons. Its weapon of choice was far simpler, itself. DART was a kinetic impactor. In other words, it was designed to slam into Dimorphos at high speed, using nothing but its own kinetic energy to alter the asteroid's trajectory. The spacecraft was relatively simple. It was essentially a box with a navigation system, a camera, and a single large solar panel. No fancy instruments or complex systems, just brute force delivered with pinpoint accuracy. This elegant simplicity was one of the keys to DART's success. By focusing on a single, well-defined objective, NASA was able to streamline the mission and reduce the risk of failure. Section 5. A Journey of a Million Miles. Planning the DART mission. Planning for DART began years before the actual launch date. Scientists and engineers had to carefully choose the target asteroid, design the spacecraft, and calculate the precise trajectory needed to hit Dimorphos with pinpoint accuracy. They also had to develop sophisticated computer models to simulate the impact and predict its effects on the asteroid. The mission also required extensive international collaboration. Telescopes around the world were used to track Didymos and Dimorphos, providing crucial data and insights for the mission. After all, this was about protecting our entire planet, not just one country or region. The DART mission was a testament to human ingenuity and international cooperation. It was a reminder that we can achieve great things when we work together towards a common goal, uniting our efforts. Section 6. Impact. After a 10-month journey, DART reached its target on September 26, 2022. Traveling at over 14,000 miles per hour, the spacecraft slammed into Dimorphos, sending a plume of debris billowing out into space. It was a moment of both triumph and apprehension. Around the world, scientists and space enthusiasts held their breath as images of the impact arrived on Earth. The moment of impact, captured by DART's onboard camera just seconds before it went offline, was nothing short of spectacular. The impact itself was only the beginning. Now, the real work began, analyzing the data and determining whether DART had successfully changed Dimorphos' orbit. Section 7. Measuring success. Did DART make a difference? In the weeks and months following the impact, scientists meticulously tracked the orbit of Dimorphos around Didymos. They used ground-based telescopes and space-based observatories to measure even the slightest changes in the moonlet's trajectory. The results were in. DART had worked. The impact had successfully altered the orbit of Dimorphos, shortening its orbital period by more than 30 minutes. This might not seem like much, but it was a monumental achievement. For the first time in history, humanity had demonstrably changed the course of a celestial object. We had proven that we could defend our planet from asteroid threats. Section 8. Lessons learned paving the way for planetary defense. DART was more than just a successful mission. It was a learning experience. The data collected from DART is providing invaluable insights into the composition and structure of asteroids, as well as the dynamics of kinetic impacts. This knowledge will be crucial for designing future planetary defense missions. We now have a better understanding of how much force is needed to deflect an asteroid, how the shape and composition of an asteroid affect the outcome of an impact, and how to accurately target and track these celestial objects. The lessons learned from DART will help us develop more effective strategies and technologies to protect our planet from future asteroid threats. Section 9. Our future among the stars. The DART mission marks a turning point in our relationship with the cosmos, showcasing our ability to alter the course of celestial bodies. We are no longer passive observers of the universe. We are active participants, capable of shaping our own destiny among the stars and making significant strides in space technology. With the knowledge and experience gained from DART, we can face the future with confidence, knowing that we have the tools and the will to protect our planet and ensure the survival of our species for generations to come. The cosmos is vast and full of wonders, and thanks to missions like DART, we are one step closer to unlocking its secrets and securing our place among the stars, paving the way for future explorations. The future of space exploration is bright, and with missions like DART, we are showing the universe that humanity is ready for the challenge and eager to explore the unknown.